We introduce a novel weight simulation method using electrotactile stimulation to create the illusion of weight without relying on mechanical or visual feedback. Slip grip simulates weight based on the relationship between perceived weight and grip force. When the user's grip falls below a set threshold for the virtual weight, slip grip delivers an electrotactile flow. Combined with the lateral force from the device's weight, this creates a slip illusion, prompting the user to naturally tighten their grip. The increased grip force makes the user perceive the device as heavier. The electrotactile stimulation delivers a sequential pattern to both the index finger and thumb. Starting from the top line, the signal moves down line by line, looping back to the top after each cycle. One electrode at a time is activated, rapidly scanning all 16 electrodes. To prevent unwanted sensations, the electrodes on one finger are grounded while the others are set to high voltage, and the opposite finger is set to high impedance. The electrotactile stimulation is synchronized with the user's grip to enhance weight realism. The speed of the electrotactile flow, or line period, is proportional to the grip force and is calculated using a specific equation. This mimics real-life slipping, where a stronger grip results in rougher, bumpier slips. The intensity also adjusts. When the grip is tightened, the stimulation voltage equals dt plus 0.75. When the grip is loosened, the voltage equals dt. The prototype is a 100G handheld device with two electrode arrays providing electrotactile feedback to the thumb and index finger, and a force sensor that continuously monitors grip force. Each electrode is controlled by a high-voltage switching module, determining its connection to the positive, negative, or high-impedance state. Powered by a 12V DC supply, the system uses a DC-DC converter for logic devices and an isolated plus or minus 100V power converter for the HV264 amplifier, which delivers voltages from 0 to 200V. To validate our approach, we conducted a series of user experiments with three main objectives. Experiment 1. Validate that electrotactile stimulation can induce a slip illusion in a weight gripping task. Experiment 2. Investigate how adapting the speed and intensity of the electrotactile stimulation according to the user's grip action improves weight perception. Experiment 3. Explore the relationship between the threshold grip force and perceived weight in actual unit. In Experiment 1, participants were asked to grip the device at different weights and electrotactile flow speeds. We found that participants required a higher grip force to prevent perceived slipping when electrotactile stimulation was active. This indicates that the electrotactile stimulation successfully induced a slip illusion, even without actual physical slip. In Experiment 2, we explored whether adapting the speed and intensity of the electrotactile stimulation based on grip force enhances the weight perception experience. We found that participants reported that the adaptive feedback felt more natural and realistic. In the interviews, 8 participants found the slip illusion realistic, with comparisons to textures like matte stainless steel and silicone. Most participants naturally increased their grip force when they perceived the slip, confirming the method effectively simulated weight, though they noted virtual weight lacked direct gravitational force. Adapting the speed and intensity of the stimulation enhanced realism, but some negative feedback included discomfort from prolonged stimulation and, for one participant, the electrotactile flow not prompting grip adjustments. In Experiment 3, we examined the relationship between the grip force threshold and the perceived weight. There was a strong linear correlation between grip force and perceived weight, though individual calibration may be needed for accuracy. This innovative approach opens up a world of possibilities, utilizing devices similar to our prototype or alternative designs that monitor grip force or deliver lateral skin stretch to create the sensation of weight. In virtual reality, slip grip simulates varying weights in VR controllers, enhancing realism in games and training. Beyond VR, it can be applied as a tangible interface in education, entertainment, and rehabilitation, offering a more interactive and tactile experience. In robotic manipulation, Slip grip improves precision by allowing users to feel the weight of remote objects, making tasks more intuitive.